Hey, what is up guys? Rayquaza-Dot here, and today we're back again for another part of our C++ tutorial. So in the last part we went over comments, source control, printing to console, and variables. So today we are going to go over conditionals and loops, and possibly something else if we have the time. But those are going to be the main focus, because conditionals covers a little bit, and so do loops. So yeah. So we have this at the moment, but we want to basically make it do something more than just print to the console. So first kind of statement we're going to go over is an if statement. So this is probably the most used, I would say. So basically the way you write it is, if we go over to Visual Studio, you go if, and since we've got some variables here, we'll say if a is equal to 3, then we open up some curly brackets, and then we'll put something inside those curly brackets to say what it is. Now, at the moment we have a assigned to something. So, at the moment, of course a is going to equal 3, but we could do something else. So before we do that something else, if you want to do something, so if, say for example, a is not equal to 3, what do you do then? So you can go else, you can either go else and then open up some new curly brackets, or you can go else if, and basically do the exact same thing. So a is equal to 4, for instance, and you can keep going. You can keep going like that with as many else ifs as you want, and you can have another, and then you can have just an else, which will just default. So you could say cout a does not equal any of does not equal 3 or 4, and then go and L and semicolon. So so as we said, at the moment, just comment that out for a minute, and in here we're gonna have a equals 3. And in here, a equals 4. So if we run this, of course we're going to get, once it loads, we're of course going to get a is equal to 3, because a is currently set to 3. So if we change a to 4, then of course we're going to get a equals 4 on this console bit. However, if we then set it to 5, then it will say a does not equal 3 or 4. So that is how we do, that's basically how if statements are done. So it will what happens is you say if, in the brackets, you need the brackets, you put the condition. So you can also do other things, not just integer variables. You can also use float variables, which are basically decimal numbers. You can do strings. You can use booleans, which are either true or false. So you can do a broad range of things with if statements, and you can also have if statements inside if statements. So currently, if we put that back to 3. And then we go if, before that, let's go if b is, and I've got insert on for some reason, b is equal to 7, then we'll open some new curly brackets and we'll move this line up into the curly brackets and indent that. If you want to know how I did that, I basically just went on the line and pressed Alt up, and it just moves the entire line up. So yeah. And then we can make a copy of this and go b equals 7. So let's run that. And of course it says a equals 3, b equals 7, and we can have an else in here as well, and we can have a equals 3 and b is not equal to 7. So if you want to say is not equal to in this thing, you'll notice the double equals sign. So if you want to assign something to a variable, then you just use a single equals. But if you want to check something in an if statement, then you need the double equals. You can also what you can also do is you can have you can have a is greater than 3, a is less than 3, greater than or equal to 3, less than or equal to 3, not equal to 3. Yeah, you can have all of those. So yeah, if we then set b to 8, then of course, when we load it up again, it's going to say a is equal to 3, b is not equal to 7. So yeah, those are if statements, and you can nest as many if statements inside one another as you like. As long as you keep track of how many if statements are inside one another and you don't confuse yourself, because that is probably the biggest problem with programming that I have with programming personally. I confuse myself quite a lot of the time. So yeah. There is also one last thing we can do to make this even better. So instead we can instead of assigning a and b like this, we can actually have before the if statement, we can go cin a and l and cin b and l. I believe that's how, or maybe I don't need the end l. Yeah, there we go. So cin is the opposite of cout. So cout will only print things, but cin will take input. So this is where we will actually be able to assign things. So if we go and run that, what are you complaining about? I am stupid. Oh, we do need to assign it. A equals b equals 0. And a equals 0. Let's see if that'll work now. Yeah, it's very important that you do at least initialize the variables to 0 if you don't want them to hold anything when you're starting. That's something I forgot. So yeah, I make mistakes as well, very often. So yeah, let's have 3 and let's have 7, and then of course that will be true. And then again, let's have 3 and 8, and voila, we get that. And then let's have 4 and 7, and we just get 8 with 4, because that's what we've done for the if statement. So yeah, cin is very useful. We can even have cout before that, saying assign a value to a, and then we can have another one afterwards that says assign a value to b, and that will at least tell them what they're doing, because cin doesn't tell you to do that, it just expects you to do that. So if you say, like, so then if we go 3, 7, all of that happens. So those are if statements in a nutshell. Hopefully that's enough. Hopefully that is enough to understand. I know I think I went over that pretty fast, but yeah. If you are still confused, then leave a comment down below after the video, and I will elaborate further if I can. So yeah, that's if statements. Now there's another type of statement. It's not one that I use often, as often as I probably should, and those are case statements. So the way you do this, so we're going to take out most of this. So we're just going to have int a for now. And then we're going to put them up there like that. So, case statements, the way you use a case statement is, if you are basically looking for certain values, then you would use this instead of an if, because it saves a lot of line space, and it's not, it's far less complex if you're just looking for certain values. So if you have in a equals 0 and you go c in a, and then we'll have, c out, enter a value for a. You can also have, if you want to put everything on a new line, you can also just go \n, I believe, and that will let you, and that will give you an extra line. And then you go switch, if I can type, switch a. And then that will open up the case statement. So then if we have, case 1, and then go c out. We're going to have a lot of c outs here. So what we're going to do is we're going to have 1, 2, 3, 4. And then in here we're going to have a equals 1, and then copy this into here, a equals 2, a equals 3, and a equals 4. So now, why are you having a problem with that? Because I'm an idiot. Right. Now, hopefully this should work. As I said, I haven't actually used these in a very long time, so I may be a bit rusty on this. So bear with me. So if we say 1, oh, forgot one last thing. If the case is met, then we should break. Right, let's try this. So if we type 1, it's just going to have 1. So what break does is it will basically stop it from processing. It says what it does on the tin. So basically, if the first case is met, then it's just gonna skip all of the rest of this. It's not gonna bother processing the rest of this because this has been met. Otherwise, if this has not been met, then it will go on to the next one and check, and so on until it's gone through all the cases, or until the case has been met and it is told to break. So that's what will happen here. So it's a lot simpler than an if statement. If statements, I would say, are a bit more easy to use. So yeah, but anyway, those are case statements. So now let's move on to something a little more complex. So I said I was going to go through loops. I then remembered something before loops. So we are going to cover something called arrays. Now, an array is much like a variable. So, but it holds instead of holding one value, it will hold a set of values that you define. So if you go, actually no, if we just use a, and call it, no, let's make a new one. Int my array, and then do that, we have successfully made an array. And then if we say 5, that means that this array will hold 5 elements starting from 0 to 4. Now that may be difficult to grasp, but what you need to remember with programming is that computers will count 0 as a number, so 0 will be the first element in here, and that is actually needed later. So we're going to take out all of this for the moment. We don't need it at the moment. So we're going to have this, and then I think we're going to go 0, 0, 0, 0, 0. So all 5 elements in this array are currently 0. Now, the other thing to remember about arrays is that when you define an array, it has to be a certain data type, and everything in the array has to be of the same data type. An integer cannot also hold a string or a float. It can only hold integers, and a string can only hold strings and not integers and floats, and so on and so on. The integer array has to hold integers, and the float array has to hold floats. So yeah, and the way we the way we print out these, we retrieve these values, is we would go my array 0 for the first element. So if we say go cout my array and L, and then if we copy that and go my array 1, my array 2, my array 3, and my array 4. Those are all 5 elements in the array, and so if we set this to like 1, 2, 3, 4, 5, then of course it's going to print out all of the elements in the array. Now, this seems like a bit much, doesn't it? Like, just on each individual line printing out all of the elements in the array. There's a way around that. So we're going to delete all of these barring the first line, and we're going to go into loops now. So loops are incredibly useful, not only for arrays but also for just checking things and not having to write multiple if statements or case statements. So if you have a lot of things to go through, like if we have an array of 500 integers, for instance, you're not going to want to retrieve the values of this or assign the values of these one by one. You're going to want to have something that does it in batch. So that's where loops come in. Now the first loop, the one that I am most familiar with and the one that I use most often, is a for loop. So you define a for loop by saying for and opening brackets, and inside you need to declare a temporary variable. Now generally this is we go int I. This is generally how we do it, and like how programmers do it. And then after the semicolon, we also need to define the boundaries. So if we say let's just go 5 for the time being. So I is less than 5, and then another semicolon, and then the next bit is going to determine whether the array goes up or down, whether the for loop will go up or down. So and to do this we go I++, and the plus means that basically it's just going to increase by 1. So what this is going to do is it's going to declare I at the start of the loop. Then every time it goes through the loop, all the lines of code, once it's done that, it's going to increase I, and then at the when it starts again, it's going to check I. I said that wrong, but so we declare in I at the start of the loop. It's going to check I to see if it meets the condition that we've declared afterwards, and then at the very end of the loop, I is going to be incremented by 1. Also, I'm going to shut my windows quickly. So, so next we open curly brackets. Curly brackets are very important in C, C#, and C++, and many programming languages, to be honest. And then we're going to take this and move it inside. So now, if we run this, it's going to print. Why are you having a problem with that? Oh, didn't initialize that, that's why. In I equals 0. So I is going to start at 0, and then, yeah, as I said, everything's going to happen. So at the moment, it's printed out just the same thing once. Now, what we can do next is rather clever. We can take out this 0, and we can replace it with I. So instead, it's going to take whatever I is equal to, it's going to call that element. So if we then run it again, it's going to print out all 5 elements in the array. And if we increase this to 6, no, let's increase it to 7, and then let's increase this to 7, and then we'll go 4, 3, and try running it again. And it's going to print out even more of them. So next we're going to do while loops. So the way we do this is we have we go while, and then we go let's use in A again. A is less than or equal to 10. That's not less than or equal to. That is. Then it's going to go cout A isn't 10. And then end L. Then we're going to go A plus plus at the end. Or we could also go plus equals 1, do the same thing. The only difference is that if we go plus equals, then we can do 2 or 3 or 4. And what plus equals does is it's going, whatever comes after it, so plus equals 4 for example, every time we go through this loop, it's going to add 4 to A. So it's going to go up in 4s instead. But for the time being, we're just going to go A++, and then round that off. So we're going to comment these out like this. And we're going to go through. And there we go. Lastly, for loops, we're going to have a do while loop. So basically, what's going to happen here is we're going to go do, then on the next line curly brackets, and we're going to go cout. Actually, we're just going to move this up here. And then instead while A is not equal to 10, move this up here as well. Yeah, so then we delete these. And basically this is how the do while loop works, kind of like this. It's kind of the same, except there's a little bit more of a step, and unlike a while loop, this loop is always guaranteed to go through once, I do believe. So if we run that, it's going to do the exact same thing and then close. So yeah, that's going to bring us to the end of this. I think we've covered everything I hoped to cover in this. Of course, if you don't understand any of this, then don't forget to leave a comment in the comment section below, and I'll try and answer it to the best of my ability. And yeah, next in the next part, we're going to go over functions, and that will be fun because it helps you so much with coding, because with functions, you won't have to do all of this procedurally anymore. So yeah, hope you enjoyed the episode, hope you learned something, and if you enjoyed the video, don't forget to leave a like to show your appreciation, and I shall catch you guys in the next part.